We are ready to start if you want.
Oh, okay. Beatrice, would you like to say any introductory words about the symposium that
Yes,
began a little while ago, earlier today? And
yes, of course. Well, first of all, I want to say that the process to have to be all we here started a year ago, I think, when Steve contacted me to see the possibility to speak about the possibility to perform a Galaxy Forum in Argentina as part of the associated events to the IAU Symposium 367, and because we will meet each other in Bariloche, and on December 14, we will take a bus and go to see the total solar eclipse. Was a really great plan past year. But after this organization, with all ready to receive you in Bariloche and have the Galaxy Forum and exchange some very spectacular chocolate from Bariloche, we are here, each one at home, and in the middle of a pandemic, and trying to save the symposium, the Galaxy Forum, and all the activities, and trying to be as happy as we can in the middle of a really hard moment for the humanity. So to me, it's a pleasure to be here. We work very hard to have the symposium in this way, a virtual symposium. A lot of people work it and is work today and will work the following days to make this possible. I'm very happy to see that we have 51 participants in the Galaxy Forums, or almost the same than in a face-to-face meeting of this level. And well, I also want to give my thanks to Steve, because I didn't know Galaxy Forum at all. Sorry, I knew the proposal last year, and I found that it's a very inspiring meeting with a very wide a spectrum of speakers and topics, but always thinking in the education in the 21st century. We need a new education, if you want, and as we learn this year with the virtuality as the new normality, we need new methods, new proposals, even new people. So we need to reconvert ourselves to teachers of this century. We need to know more proposals. We need to know more people. And now we can contact anyone, anywhere. And this is part of the good things of this year. So it's a pleasure to me to give the words to Steve. And thank you to Think in Argentina for this Galaxy Forum. I know that the speakers are very good speakers with specialities very interesting, a bit different to the what we have at the symposium. So thank you very much, Steve, and a great Galaxy Forum. I hope the first Galaxy Forum in Argentina.
Gracias, hola, and as we say here in Hawaii, aloha. Thank you so much, Dr. Garcia, Beatrice, a wonderful introduction and a wonderful effort that you and I believe all of us are making today with this commitment of our time and energy on such an important subject as the universe, the stars, our subject. And I want to thank once again our distinguished speakers, none of whom I've had the pleasure and privilege of meeting yet in person, but I hope that will come as we transcend and succeed over our immediate challenging environment in the health emergency. By the way, Beatrice, I do notice that Dr. Li Geng is on the symposium right now. I don't know if you want to put his image up or not, but he is with us. So to begin, and as Dr. Garcia, Beatrice had mentioned, we have some extra time if we need, but we'll proceed per the schedule. Let me see if I can get my PowerPoint up. The green share button, okay? And then just the slideshow here. That's it? Okay. Okay. All right. Well, there's our formal slide for the Galaxy Forum South America. Our first Galaxy Forum in Argentina. This is actually the 102nd, 102 Galaxy Forum of this program that began in July 4th, 2008 in Silicon Valley. And the cover slides there, the cover slide depicts the rather graphically where we are, some of the focus that we will bring, specifically precession and the moon and the galaxy stars. My very talented associate Elisa did this composition that you see there. And through this presentation, it's experimental and introductory for me, trying to fuse together a number of prominent themes and interests of my work and pursuits over the decades. So bear with me if some of the transitions aren't totally clear or smooth. This is pioneering work as far as I'm concerned. Precession, constellations, epochs, and astronomy from the moon. That's a mouthful. I'll start with something most familiar to me, our organization here in Hawaii, the International Lunar Observatory Association, ILOA, with the purpose, like many observatories, to expand human understanding of the cosmos through observation from our moon. And there's the difference, a new frontier for astronomy, with Aloha. How we go into our explorations into space is most important, like I believe how the IAU operates with its values and core principles. ILOA was founded here in 2007 in the town of Kamawela on the north central part of the big island of Hawaii. Right next, our closest neighbor, just a few meters away, is the Canada-France-Hawaii telescope. We have 27 distinguished international directors, including 4 astronauts, an operational executive committee here on Hawaii Island, keeping day-to-day progress moving forward. The ILO, and you see it pictured on the left, our artist did some work there, showing the flagship ILO 1, we call it, perched on a summit on a peak of eternal light. It's nicely called, poetically called, at the south pole of the moon, taking first light from the galaxy and transmitting astronomical, astrophysical data back to Earth. The ILO is multifunctional, as any first pioneering venture tends to be. Observation is first, the galaxy astronomy, the Earth and the moon are prime objectives of observing. Besides observation, we're very much involved in communications, scientific at first, and then eventually with our affiliated parent company, Space Age Publishing Company, commercial communications as well. And we hope to participate and facilitate lunar-based build-out. Astronomy from the moon is what we're talking about. Truly a new frontier for astronomy, for astrophysics, after the venerable research of thousands of years here from Earth. more recently the past 50 years with space observatories, and the moon is indeed a new frontier, just beginning now. Many ventures are being proposed. And this has been a thought and an attraction since the beginning of the Apollo program in the USA in the 1960s, the idea of doing astronomy from the moon for some very obvious and some not so obvious reasons. And we believe that astronomy from the moon will be one of the more widespread activities early on the human settlement and operations on the moon. In other words, a first light industry on the moon, and that works in several ways, a first light industry. We hope, as I mentioned, we'll be looking at the stars. First light will be aiming to get the first image of the Milky Way ever from the moon. And what will be significant of that story is that it's an engineering first and represents humanity's first permanent step forward out into the galaxy. That first image of the galaxy from the moon may be as iconic and influential as the first image from the moon in the 20th century, back of Earth, where we understood our climate and our environment and our spaceship Earth so much better. Besides the galaxy stars, we hope then to conduct Earth observation, not just space weather and climate change and environmental considerations, but a growing interest of mine, actually an interest of many decades, rotation of the Earth. One of the first commissions of the IAU was a commission on rotation of the Earth. In order to get more accurate values of precession, and the precession of the equinoxes, which I will talk with as a major part of my talk shortly. Besides stars and the Earth, which has many, Earth observation has many practical applications as well as astrophysical ones as well. Tilting our camera down further from the stars, across the horizon of the Earth and down to the lunar surroundings, we hope to be able to image developments that are going on in the area. And of course, like is true on any world, the whole universe can be viewed and observed. VLF is now is currently being taken on the far side of the moon by the China Chang'e 4 lander, conducting the first astrophysical observations in VLF on the moon. SETI, which I'll have something to talk about, things to talk about shortly in another slide, can also be conducted very advantageously from the moon. Detection of Earth approaching objects, solar storm observations, and many other applications and observations are possible from the moon. Now, precession, as I mentioned, and we hope that our ILO1 can conduct Earth observation, and more sophisticated instruments get even more precise values of Earth axial precession, which has been described by Copernicus as Earth's third motion, Earth's third revolution. And from those observations, we can determine much more accurately the precession of the equinoxes and gain more accurate values for the Aquarius, the much talked about Aquarius equinox epoch. There is a few simple diagrams showing the precession of the equinoxes caused by the wobble, as you all know, the wobble of the Earth, the fact that the Earth is not perfectly spherical. It wobbles on its axis, and the axis circumscribes against the sidereal sky a circle. The North Star, in other words, changes over time as the Earth axis wobbles and carves out a circle in the sky, and simultaneously precesses through the zodiacal constellations. And that point of precession now has reached a point where the idea of the Aquarius epoch has become a popular cultural consideration. Upon further examination, we find that by the IAU map, the official map of the IAU constellations that was approved on top of the work of Eugene Delporte in the 1920s, shortly after Einstein and Hubble made their discoveries on relativity and galaxy awareness. The official map, based on 1875 coordinates of right ascension and declination, shows that the Aquarius equinox epoch arrives in about the year 2600. So a long dawn indeed. About 25 years ago, playing with a Photoshop type software, I realized with a slight change of the constellation boundary, the Aquarius boundary, that Aquarius equinox epoch would begin at that 0 point there at epoch 2000, the year 2000. Excuse me a minute. So what is interesting also is 20 years after I published that map, looking at alternative constellation boundary that would realize the point at which the sun appears to enter the constellation of Aquarius at the vernal equinox. That's what we're talking about. About 20 years later, in 2017, dramatic astronomical discoveries were announced regarding the TRAPPIST-1 system, which, for reasons that I'm not totally clear, was detected and observed to be almost precisely at that part of the sky that we were considering these changes. And with that, in TRAPPIST-1 and the interest and excitement that it generated, not just astrodynamically, the fascinating interplay between the 7 planets revolving around each other, but the prospects for life being able to be generated in that system with Earth-like planets in that TRAPPIST-1 system. Seven planets and planet 1 Echo, 1E, as Echo, as Buzz Aldrin likes to call it, is a very has generated great interest. Many papers, many professional astrophysical astronomical papers have been generated by University of California, Berkeley, by the SETI Institute, by many universities. An interest in the prospect of astrobiology, or in colloquial terms, star life, is growing with potential next generation telescopes soon to come online. So what colleagues and I and those interested in the TRAPPIST-1 system have been developing is a working group to search for life in the TRAPPIST-1 system in the Aquarius constellation. And that group has not yet met, but we've been talking with people who have expressed an interest in participating in the TRAPPIST-1 SETI Aquarius working group. Most surprisingly to me was Buzz Aldrin, who was the first to land on the moon with Neil Armstrong in Apollo 11. He took the initiative, expressing his strong interest in the TRAPPIST-1 system and his thoughts, not just aeronautically, astronautically and astrodynamically, but astrobiologically, and laid out his thoughts to me and said, see, Steve, see if you can find some people who are similarly interested and get back with me. And that's what I've been working on with my associate in our California office, who's watching this presentation, Labiba Boyd. We've been outreaching to Jill Carter and Seth Shostak and a number of other prominent SETI people. Bill Waller, who's interested in SETI, maybe not that much in TRAPPIST-1, but that's a good place to start. Margarita, she's with us on the screen right now. from India, from Bangalore, Nikos Prantzos, a participant in the IAU symposium today, and a number of Korean astronomers and many more that will be expanding this group to explore astrobiology, to search for life in the TRAPPIST-1 system, and to prepare to use the telescopes that have already provided a lot of information on the TRAPPIST-1 system, Hubble and particularly Spitzer. The Allen Telescope Array, as Seth Shostak has conducted extensive searches in the TRAPPIST-1 system. The new China telescope in Guizhou, the fast 500-meter telescope, and the JWST has a study group already formed to study the TRAPPIST-1 system. Yes, Jill Tarter in particular has given us information and leads to the JWST research system. Our ILO1 hopefully will be imaging the TRAPPIST-1 system, and then the next generation large telescope in Chile, and the big Hawaii telescope here that has met some problems, but is hopefully going forward sooner or later. Regarding the Aquarius boundary update, as we like to call it, the rationale on your left, caused by precession, the force that is generating and making inevitable the precession of the equinoxes, and the change, the updating through the need through the forces of precession, of relativity, of galaxy awareness. Einstein and Hubble had not made their great discoveries when when the coordinates were taken that made the 1930 constellation map, the 1875 data. By updating the Aquarius equinox epoch to start an epoch 2000.0, we think it would advance both IAU science and society imperatives per its IAU strategic plan 2020-2030. Goals 1 through 5 would be consistent with advancing and upgrading and updating the Aquarius boundary, especially similar to the IAU strategic goal 2, to foster inclusiveness. An Aquarius boundary update with an Aquarius equinox epoch 2000 resolution, and it's a resolution that we're ultimately talking about eventually with the IAU, through the IAU. It would amplify 21st century egalitarian considerations for equity, diversity, and inclusivity, all very strong egalitarian traits, which I think will be a necessity for a multi-world species that we're on the eve of becoming. And it will be good for the IAU, for astronomy and humanity. And like inclusiveness, it's the right thing and the correct thing to do. All of those IAU committees, working groups, especially the equity and inclusiveness, women in astronomy, archaeoastronomy, the symposium that was held last year at NAOJ Japan for equity, diversity, and inclusivity, today's symposium, the divisions that I participate in, and the General Assembly now postponed in Busan. We're not sure about the resolutions session, whether that will be postponed or be conducted virtually next August. But these are all the considerations that go into the Aquarius, the advantages of updating the Aquarius boundary. And that, I know I'm a few minutes over. I'll take that out of my concluding 5 minutes if necessary. I don't want to take more than 1 minute to go back to my home base here, the moon, and There's the ILOA, our flagship on the upper left. On the lower left, we actually are going to the moon in 306 days. We have a launch with our two very small precursor instruments that are scheduled to land on the moon fourth quarter next year, and hopefully succeed in taking the first image of the Milky Way galaxy ever from the moon. That'll be a few years before the landing of the first women on the moon, that our organization has been at the forefront of advancing the last 3 or 4 years, and rather hopefully, since it will be a significant event for the 21st century when the first woman lands on the moon, as was the landing of the first men on the moon in the 20th century, and why shouldn't it be? Okay, well that's my presentation. Don't know if there's a question or two. I know I'm a few minutes over, but I do believe that Dr. Garcia Beatrice mentioned that we have a little bit of stoppage time, a little bit of extra time at the end to take if necessary. So thank you very much for your attention.
Very good. It was a really interesting talk, Steve. I don't know if you want I help you with the talks, or you will manage all the forum.
Okay, I think, Beatrice, I think I can move it along. Elisa, would I make the next introduction then? Just go ahead and do that. Okay,
Well,
I think we'll proceed. Okay, Beatrice, please stop me if necessary. But I'd like to continue where we left off with some concerns about the moon and Argentina astronomy. Very pleased to make the acquaintance and hear the presentation of Dr. Marcelo Colazo of CONAE, the National Commission of Space Activities in Argentina. And Dr. CONAE helps administer the Argentinian space policy and direct its technology in space for peaceful purposes. So please welcome Dr. Marcelo Colazo speaking to us today about CONAE's activities related to deep space antennas. Marcelo, please.
I'm sorry. Thank you very much for the introduction. I will now share my presentation. I'm sorry, I'm trying, but I don't see the application. Oh, here now, yes. Is it visible now?
yes, Marcelo, we can see and also hear your voice.
Okay, now it's okay. Okay.
But it's not in the presentation format yet. It's we see the PowerPoint.
No?
Okay. Yes, perfect.
Okay. Okay. As Steve said, I am from CONAE, that's Argentina Space Agency. This agency was created in 1991. Now it's under the Ministry of Science and Technology. We have a national space plan that was developed the first version in 1994. And for the Pacific use of the space science and technology, based mainly on international and national collaboration. The the first version of this national plan was more oriented to observation of the Earth, but with the years, it's been changing, suffering some updates, and now includes some topics as space exploration. And one example is the one I will make with this presentation related to international and national collaborations. As you probably know, there are deep space station installed in Argentina. When ESA, the European Space Agency, decided to have its own deep space network, installed the first in Australia, then a second one in Europe, and the last was installed in Mendoza, near Malargüe city. This process originated in 2007 with a search for place that took more than a year. And after searching places in Chile and Argentina, they decided to stay near Malargüe, near also a place. It was 200 from the capital city to the south. And the image you can see, the station is the antenna and the buildings that compose the station. Here, as is needed for space exploration and communication with missions that are some million kilometers away, this antenna has a big disk. In this case, it's 35-meter diameter. It works in X-band and Ka band for communications. Works also with, allows you to use both circular polarizations. And in 2019, the station was updated to include a K-band because the requirements of the new missions of ESA needed more speed for data transmissions. One of the most important aspects of this collaboration with ESA was that when we signed the agreement, it was Argentina got 100% of the operational time for use for local projects, also for TTC communication and also for other scientific projects. The same way, China, for support to their lunar exploration program, in 2010, start looking for a deep space station outside their country. They had at that moment 2 stations inside China, but that didn't give them a full coverage of the mission. So the same way that ESA, they look it for a place in South America to have their own station. And after also a search in places in Argentina and Chile, they decided to install a station near Bajada del Agria in the Neuquén province in Patagonia. This station is very similar to Malargüe station. We have also 10% for national projects. The main difference is in the frequency that operates the station, that it included an S-band capability for transmission and reception. These are very modern stations that have very good capabilities, technical capabilities. They need to communicate with missions that are very far away with very weak signal. So the electronic is very sensitive. They provide atomic clocks for for timing and frequencies. So they are very interested to use it as a radio telescope. So in 2011, when Malargüe was building, the local scientific community showed the interest of using this station for astronomical observation. Mainly, they provide some topics that here I list some of the more important. That is, for example, to look for the resolution of the station allows to be very compatible with the search for counterparts for gamma ray sources that are not identified. For example, you got from Fermi more than 5,000 gamma ray sources, but there are many of them that are not identified with another source in another frequency. So it will be a good opportunity to look for in radio to look for these counterparts. Also to be able to study radio galaxies in the south, as Centaurus A, for example, Circinus. Also to get time to make some long-term analysis of variability for nuclei of active galaxies. And you have the opportunity to have time when in a system that is more that have the ability to make the study in different frequencies with different polarizations. Also to make some observation on non-thermal sources as supernova remnants or thermal ionized regions, to make some astrochemical study spectral lines on molecular clouds, also pulsars, to do VLBI with other stations. We had some experience with Malargüe and NASA in that observations, and also radar using the capability of transmission that this station has. We started in 5 years ago with making some observation and testing, because the equipment that has the backend that provides the station are devoted to communications, so it's not the ideal tool for astronomy. But we started with ITEA, with Beatriz García, working making some observation, some continuous observation of some sources, radio sources, where we were able to see that even though the equipment was not the ideal, it was possible to make some astronomy observations. Here you see an example of active nuclei galaxy where we have make a grid and observation of the flux of continuum in X band. The same way we have tested also with Ka band. This is made in with Malargüe equipment. Also, we did after the inauguration of a station in Neuquén, we made also some observation the same way, continuing to test equipment but it was very different and somehow was not so easy to configure it. And we were able also to make some observation and make some observation of test, but we defined that the way to extract the most from this station was to use an equipment that is made for astronomy. So last year we went with investigator from the Argentinian Institute of Radio Astronomy. They had the institute had two 30-meter antenna that works in L band, and they have developed a backend for the observation. So we made some tests of using this backend with the station of Neuquén. So we integrated the equipment and were able to make some continuous observation of radio sources that were successfully detected. Here you see flux of continuum in S-band. Also, we made some pulsars observation. The group in the Radio Astronomy Institute, they work a lot with pulsar. So we were able to observe and put the data into the software that generate the products and detected the pulsars. Also, we use the capability of transmission of the stations for doing some radar tests with a station of at the Institute of Astronomy of the Russian Academy of Science. They had a network of Russian telescopes, and they don't have the capability for transmitting. So we use this capability of Neuquén antenna and make the observation of the moon, and the signal was measured in the network in Russia. This was a first experiment that was successful. The pulse, the echo was detected and measured in the Russia stations. We made also another test using an asteroid, trying to observe an asteroid this year, but was a problem with orbital determinations, and there was not signal received. So we are planning to have more observation in the next year. Also, for the eclipse, we with colleagues from JPL of NASA, we planned try to observe from Malargüe during the eclipse active areas of radio emissions, and use the moon as a way to get more details beyond the resolution of the antenna. So we plan some observations with Malargüe using the capability that the station provides, and we observing both bands that were available, both polarization, and make some. We made a grid where we swept during the observation, and were able to make a map in both polarizations. And in this case, we are not detected active areas, but this is the way that we are going to observe next week, and we expect to have some results. Other thing that we are working on regarding the use of these stations is with the Institute of Radio Astronomía, with ITEDA of Mendoza, with the development on a specific backend for astronomy. The station provides more capability that we can use using the equipment for communication. So we are working on this equipment. CONAE make the purchase of the parts, and the Institute of Radio Astronomy will be building it in the first months of 2021. And we expect it to have it operational for the second semester of 2021. And my last slide is about, I want to share with you that CONAE, since last year, is offering the possibility to local investigators to use the 10% time that is offered to Argentina for science with the Deep Space Station. It's also available for international investigators associated to local scientists. So we have already some proposal that we are under study to be able to, they will be able to observe, make the observation next year. So, well, that's it. That's what I had to tell you about what CONAE is doing with the space stations. Thank you.
Well, muchas gracias to you, Dr. Colazo. That was very interesting. I imagine that many of us watching found much new information there. As I say, we have yet to have a Galaxy Forum in person in Argentina, and I certainly would like to include your work, and very, very interesting. I'll look forward to studying your presentation from the recording. I may have a request for you for more information and questions. But I found that very exciting overview of CONAE from terrestrial observations to the moon and asteroids and the sun. Very, very interesting, and the galaxies. So thank you very much. I don't know if Beatrice, if you're monitoring this, if there are any questions. I don't see any in the chat box, but I'm not an expert on this system.
Yes, for a moment, we have not questions, but I am written that we expect questions, and the speakers will answer at the end of the complete list of speakers. Okay.
Okay, as I understood you saying that questions are open to be placed, and perhaps if they don't follow an individual speaker, that would be okay too, or at least at the end. Anybody who does have a question, we can accommodate the opportunity for their question. But I wanted to thank once more Marcelo Colazo for that very interesting introduction to the Argentinian Space Agency and the wide variety of research and applications that it's involved in.
Thank you very much.
Muchas gracias. Thank you. And so moving on, I'm very happy to make the visual acquaintance of a woman that we've been an astronomer we've been communicating with for a few years, and every time we try and have an event, it gets moved or canceled or something, whether it's Hainan, China, and there was a spectacular launch there to the moon last week, or Thailand, and here we finally meet in Argentina. Margarita Safonova is active in the IAU, of course, and a visiting scientist at the Birla Institute near the Indian Institute of Astrophysics. By the way, Margarita, I noted that the Birla Institute is right around the corner from the Nehru Planetarium.
Yes, right across.
I've had many activities there, including we've had a Galaxy Forum with Professor Rao and the President of India some years ago. So I know where you are. And
I am in both Indian Institute of Astrophysics and Birla.
I see. Well, that's really the center of India astronomy as well as space exploration, Bangalore. And Margarita is an astronomer with a strong biological inclination, such as searching for life, perhaps.
Even some background.
Including her interest in research in exoplanets and our common interest in astronomy from the moon. There aren't that many astronomers who are that interested in the moon, but that's changing. And Margarita is looking forward to collaborating on our TRAPPIST-1 SETI Aquarius working group. Looking
Steve,
please unmute your mic. Yes, you have muted. You are muted.
You
Steve.
got muted accidentally.
Yeah. No, Steve, can you hear us? You are muted. Okay.
You cannot unmute him.
No, well, I will check.
Okay.
Yes, now it's fine.
Okay, all right. Well, I hope you were able to hear some of my comments about Dr. Safonova. Margarita will be talking about her work with the LUCI project, LUCI, the Lunar Ultraviolet Cosmic Imager. So, Margarita, the video is yours. Thank you.
Okay, thank you. So now I'll try to share my screen and presentation. Click share and on.
Perfect. We can see it.
And can you see it as a? Oh, yes.
Perfect.
Thank you. So this more like not so much as about observation as UV astronomy from the moon, but as a prospect of UV astronomy from the moon. So the journey of our LUCI. And these are all our team. There are more people in collaboration with Team Indus. For every human endeavor, there are always people asking questions, why? Why go into the space when we can observe safely from the ground? Why go into the moon when we can observe cheaper from the near space? This was earlier. For example, space travel is at a bilge, was claimed in '56, and that was British astronomer. And on the eve of the Apollo 11 landing, he said, from the moon of point of view of astronomical discovery, the moon landing is not only bilge, but a waste of money. And this is happening even now. The referee of our last paper on LUCI asked, why do we need to go to the moon? Why can't we launch on the CubeSat or suborbital flight? Well, I wonder if Apollo astronauts will ask the same questions. I don't know what they would reply, but I can find few reasons. Observe from the ground, they say. Or go to the low Earth orbit. But the next logical question, of course, is going to the moon. We astronomers, we seek these clear skies. And we had an opportunity, which was the Team Indus mission, Google X Prize Indian entry. And they offered us space on their lander. Said, do you want to send anything? We said, yes, yes, of course. We'll send the telescope, we'll build it. Well, lunar exploration is becoming increasingly crowded. So much so that in the recent NOVA, Network for Ultraviolet Astronomy meeting, just some 2 weeks ago, the concern was reason saying that very soon the sky on the moon will not be clear at all. All the human activity within a couple of decades will raise so much dust so that we will not be able to observe. So that, and then I said that then it is now that is the best time for astronomy from the moon, before the human activity raised all the dust. But it is still possible that if it happens, we will go to the deep space, like, for example, in Star Trek universe, Margot's Observatory. Well, astronomy was always at the forefront of the human space exploration. Moon itself has no dearth of scientific instruments, both on surface and in the orbit. Well, and being Russian, I can't not brag about lunar series and all the instruments that, all the scientific instruments they had, all these landers and orbiters had with them. And of course, Apollo missions in '69 and '72, Chandrayaan, Changiz. But most of these missions were aimed at studying the moon or interplanetary space itself, rather than using it as a basis for space observations. There are pros and cons for astronomy from the moon. No astronomic related problems, no sea, no wind. Observations can be made continuously if you shield the telescope from the sun. Lunar surface and low gravity of a stable platform. Slow sky rotation gives very long exposure time. Then minuses, of course, there are. So, for example, low Earth orbit is easier accessible for repairs. However, the only telescope ever repaired in space was Hubble, not any other ones. And going to LEO, one of the other minuses, is cheaper. But it doesn't stop us from sending deep space telescope to all the Lagrange points, Spitzer, spectrogramma, Gaia. Then radiation environment is more benign. And dust and micrometeorites are there in the lower orbit. However, all the lunar ranging retro reflectors, including Lunar Hot 2, which was launched in '73, landed 70s are still functioning at some level. Sorry, I can't. However, ambitions were always for the large lunar telescopic installations, like 100-meter mirrors, 30 tons of radio antennas, driven possibly by the fact that since we are going to the moon anyway, we can make it big. However, there is a very nice cartoon which says that there is a big science and there is little science. It's not necessary that big corporations can make big science. So UV from the moon was done by one of the very first missions there, let's say in '72 by the Apollo 16 team, and they gave us a fantastic image of the Earth exosphere, and they could see stars as faint as magnitude 11. And now LUT robotic telescope on Chang'e 3 with 2 hyperbolic mirrors, magnitude limit was a B 13.5, which is quite good. And it gave us that nice image of Pinwheel Galaxy. Unfortunately, in 2018, the telescope was switched off, though according to certain sources, they could have been still operational for some even more than 30 years. Science cases for the lunar UV telescope are many. Major of them are, well, what we are interested in transient events, and in the UV background. And of course, looking at the Earth is very important. Early detection of new and potentially hazardous asteroids is very important. Here I gave a small table of transients and amplitude, which can be detected with the lunar ultraviolet telescope. So our first incarnation, Luci first incarnation, is lunar FUV telescope, because the weight limit that Tim Indus gave to us was 15 kilograms, and we had the detector, and we were very happy. Yes, we said we will do that, and these are the first specifications, and this is how the Luci was supposed to be put on the lander, and down there the pictures of the actual model. Let's say volume model of Luci, or original Luci, and we could orient it from zenith to horizon. And we even got into Discovery Channel with our first prototype, first Luci incarnation. But as time gone on, the weight was getting decreased and more. Finally, they told us that weight cannot be more than 1.3 kilogram, which limited our, of course, detector choice, aperture diameter, and so on. And what is interesting is that when space missions are planned, it's usually the science that drives the design. When the big missions are planned. Here, it is actually this design concept that defined our science goals. So when astronomers are limited in what they can use, we have to be inventive. So we have to invent our science. And we did. We said that, yes, okay, we will make it near UV. We will make it a transit telescope. We don't have to move. And we'll study bright UV object, and we'll study variability and transients. And this is our second incarnation, and the position of the new version of lander with inclination of 25 degrees from the zenith to avoid horizon glow, which is very well-known effect. But it doesn't go more than, let's say, 30 degrees above the horizon. However, other orientations are also possible if any need arises. So this is the instrument overview. Detector is UV sensitive CCD, and it is all spherical mirrors. And we adopted spherical mirrors because it was easier to manufacture and align, and it was cheap. It was affordable for us. Band of operation became NUV, which is from 200 to 320 nanometers, and the weight became 1.2 kilograms. Science objectives, these are our calculated loci of Luci pointing in a lunar day that we could cover. And our objectives are mostly transients, variability, flares, Luci detection. Here I present the picture of a plot of Luci detection limits for up to 1,000 seconds and 2,000 seconds. Optical design. So the primary science goals required wide field, relatively wide field of view, half degree, approximately high throughput. And that is why we selected spherical mirrors. And to meet the low mass and unknown launch load requirements at that time we didn't know yet, Luci is housed in a tubular structure, and this structure was made from CFRP, which reduced the weight, total weight, just to 1.2 kilograms. We calculated, of course, there is light scattering in ultraviolet, we have to avoid it. So if we point to zenith, the sun is always more than 40 degrees away. And in case of 25 of zenith, we were hiding behind the structure because that 25 was because of the lander. Scattering of sunlight from the lunar surface is less of a problem because of the low albedo in UV. And we could, so to prevent all internal scattering, we painted with Ira glaze, which suppressed 95% of incident light. And this is a photograph of Luci in our clean room. We designed the baffles, additional protection from the scattered light, and calculations showed that yes, scattered light is suppressed to the order of 10 to minus 14. The door, of course, we needed the door because Luci was to be stuck outside the land and flown all the way from Earth to the moon. So the mechanism for opening the door was suggested to us by Team Indus, and it was quite ingenious. That was a nichrome wire, electric connection, and the beryllium straps. So what happens is that when you send the current, they burn the wire and the door opens. So this is one-time open door. So this door open configuration. We performed, of course, all the final element analysis to, by that time we knew the launch loads, and to calculate all the launch loads, and results showed that payload is able to withstand all the launch load up to 25G in all axes. And this structure is a stiffness-based design and everything. And moreover, the central flange at the center of gravity could be easily mated to selected flight provider. Not only, it can be mounted not only on the Team Indus lander. Thermal analysis we also performed because we know that temperature fluctuates quite widely. But what is interesting is that thermal stresses in the telescope would be much reduced on the moon comparing to the space telescope, because sun moves quite slowly in the lunar sky. And the illumination is more or less uniform, whereas the space telescope really is subject to a very large temperature gradient. So actual lunar environment is strongly favored if we want to provide, if we provide suitable shade, which we would have done. So Luci would have been covered with the MLI to achieve the thermal insulation, and the possibility of active thermal control system would also have been provided. The detector and the filter, Luci had one UV solar blind filter, sorry, not solar blind, bandpass, wide bandpass filter at UV sensitive CCD. Detector and electronics was also made in our institute, 3 PCBs stacked after one another, and maximum data transfer possible was 1 kbps. So we decided to transmit only a 10 by 10 pixel window around the point sources. So we would detect the centroid and transmit only that. So we were geared for the transient sources. This is the schematics of assembly and calibration of the infrastructure that we have at our institute. Clean rooms from 100 to 1,000 first classes facility is available, and sub-assemblies were done, assembled, calibrated, and everything was aligned. These are the photographs of alignment of Luci. Optical performance was characterized, and sensitivity was measured, effective area was measured, and sensitivity plot shows that Luci's limiting magnitude is around 11 to 12 AB magnitude. And the total effective area is about 150 centimeter square, which is quite good for the telescope with only 8 centimeters aperture. Field of view and plate scale, PSF measurements were all done. And our field of view was measured within the parameters that were proposed. And this is the final, Luci's final assembly. So why Luci is unique, what we would like to stress is it, first of all, it can absorb bright UV sources. So brighter than 12 magnitude. In other words, our brightness limits is 2 magnitude. None of the UV current existing observatories can absorb those bright sources because their detectors will be damaged. But UV sensitive CCD allows it. And it is the lightest UV telescope till now made, 1.2 kilograms, and the cost is less than $10,000. Dimensions are small. It can fit into 3 to 4 CubeSat platform. And the flexible design of Luci and its moderate demand on spacecraft resources make it compatible with any lander. So in principle, we can test the suitability of the moon for the types of observatories that have been proposed, UV observatories. And Luci also being on the lander, access how stable the surface is under the stresses on rock and regolith below. One of our Luci made it even to the cover of the journal in Astrophysics Space Science. So currently Luci is in the box in storage, sitting in class 100 room. The box is under regular grade 5 nitrogen purging. And this is the real photograph of the Luci being packed into the box, waiting for the launch. We had an opportunity after Team Indus couldn't secure a launch. We were waiting what will happen, and Team Indus made an extension to Orbit Beyond company, and they made a contract with NASA, at least right to proposal. So Luci passed first step of this proposal, and it nearly passed the second step of the proposal, but then something happened, and that's it. Unfortunately, this program failed, and Luci is still waiting for the launch. But we're continuing with our space instrument development, and we have several small payloads ready to fly. One of them can even go to the moon. And this is called NATS, NUV Transient Surveyor. We have designed and built a wide field near UV imager, which can be flown on a range of platforms, high altitude balloons, which our institute have very extensive program in, CubeSats, or even large space missions. As I said, it may even go to the moon. The structural layout is shown here. With it is made aluminum alloy in VAR for mounts, and one mirror, Zeradur, and 2 lenses, fused silica. And detector is intensified CMOS for tech and sol blind for the cathode. Interfaces with spacecraft are variable, can be 1553, RS485. So optical layout was made originally to fit into 6U CubeSat. This is the sensitivity, so this instrument is also assembled and calibrated and sitting next to Luci in the class 100 room. Magnitude range is 7 to 21 AB, which has much deeper sensitivity limit, and time resolution 2 milliseconds, spatial resolution 13, field of view 3 degrees. This is the CAD design of the instrument, and originally proposed to be interfaced with center of gravity. With this flange was supposed to be fit into 6U CubeSat. However, now I'm thinking that in principle we can put it even on the lander, like for example original design of original first Luci incarnation on the lander was to hold at the center of gravity like this. So this can be adapted, nuts can be adapted to this particular holder, for example. This is a table comparing recent and future NUV missions. Galaxy decommissioned, UVAT is flying, but NUV channel has failed. Luci and nuts, and Cute is the future small UV mission, which is supposed to be flight next year. European and Colorado together. And you can see that though our Luci and nuts are small, they are ready to fly, first of all. And second, their weight is very small. And the cost, of course, is incomparable to the other missions. So here are our references. We have 3 papers describing everything from our ideas and what science can we do with lunar telescope, with lunar ultraviolet telescope, which is in APSS first, and second prospects optomechanical design and assembly and ground calibration of Luci. And in paper on nuts is in preparation. So this, I would love if anyone would go and look at our ideas, a prospect for UV observation from the moon, because there we really described everything that can be done in FUV and ultraviolet from the moon. Thank you.
Great.
Thank you.
Thank you very much, Dr. Safonova. Rita, that was a very impressive presentation on the even more impressive work that you've done. And you're right, we certainly have to find a way to get Luci to the moon.
Absolutely.
I think there's one question for you. I have an obvious question about what is the in ISRO and the IIA position on flying Luci on Chandrayaan 3 or 4? Is that a possibility? I'm sure you've looked at that, but that's what comes.
Yes, the problem with the ISRO is that they're a huge space organization, really huge. They don't look positively at small missions, at small instruments. They prefer something really, that's my impression of working with ISRO for many years. They would rather have huge mission, which promises enormous amount of return and costs, enormous costs. Though recently, as I said, we do continue with our payload development. One of our students developed very cheap star sensor, and one of the proposal of ISRO came to everyone saying that we have the stage 4 platform, which they plan to stabilize, and anyone, that was a call all over India, that anybody wants to propose some instrument on it. So we proposed our star sensor, and this star sensor was accepted. But that is for stage 4 platform, which lives on the orbit, maybe 5-6 months. Right. Otherwise, other than that, Team Indus failed precisely because of Chandrayaan 2, because ISRO did not want to fly anything for anyone unless they do fly Chandrayaan 2. And by that time, the Google X Prize withdrew there. So,
well, as you said, Margarita, that there are all sorts of opportunities that are opening now. Private missions, such as the one we talked about, that are our little precursor, which is only 0.6 kilos, will be flying on with Intuitive Machines, one of the Houston, Texas, NASA awarded CLIPS companies, and that's next year. And then they have a mission the following year that maybe we should talk about.
Yes, I wish we were with you from the very beginning, and I wish we didn't start with the Team Indus.
Well, it's difficult, but less and less expensive. And I think astronomy from the moon, your UV is always a good first choice, and the whole range of the electromagnetic spectrum is possible from the moon. Many locations on the moon.
Why UV is good is because the sky is dark in UV. That is what, unlike, yeah.
Of course.
UV sky is generally dark, and that is why the UV sources, they do stand out.
Yes, yesterday NASA had a press conference regarding the Artemis III lander. What will the science that Artemis III, when it lands sometime in the mid-decade, what science will it conduct? And one of the 7 major areas that they introduced was astronomy. And again, I think that we're on the right track. It's a good first light industry, as I like to call it. There was one question I see on the screen. I don't know if any more have come in that you're aware of, Beatrice, but a question from Walter Guevara asked, and I'm not sure that there's an easy answer to this. China was the first to propose the installation of an astronomical observatory on the moon. I'm not sure that's true, and now they are leading the way in exploring the moon. Do you think that all this interest was because they have found a commercial interest, or is it only an interest in scientific knowledge?
No, what I think is that it's both. It's both. Because China is not only an installation on the moon, it is going to Mars, and it's going to make its own space station. By the way, which another of our payloads is accepted for on the China space station, proposed it's ultraviolet spectrograph. And so China is has both. I am sure it is both, because we know that China is an ancient civilization and their interest in science is deep.
Right. Well,
if you permit me something, I would like to hear the opinion from Marcelo, because Marcelo is working directly with China right now, and perhaps he has something to say about this question also.
From institutional point of view, I guess that the interest is the technological and the astronomical advantage that you can get. But obviously, from a personal point of view, I get it's a excellent business to make this to go to the moon. So I guess that it would be an advantage in every in every branch that you consider.
I'd like to add also, Marcelo and Beatrice, that ILOA has had a MOU working with NAOC for 15 years, and we did collaborate with the Chang'e 3 LUT. The image that you showed, Margarita, the spiral galaxy M101, was the image that we collaborated to obtain with the NAOC astronomers. We did that research here in Hawaii, and assumed that we would be able to image the M101 spiral galaxy, the first spiral galaxy ever imaged from the moon. So, but I think Marcelo and Beatrice, Margarita, as I mentioned, the interest in astronomy from the moon, it's almost obvious, you know, right from the beginning of the Apollo era, the 1960s, there were these dreams and ideas, many proposals for many different wavelengths, many instruments, many locations on the moon. And I think that will, as the reality of returning to the moon approaches, many opportunities and the obvious advantages will become apparent. But what you say is quite true, Marcelo, Margarita. So very exciting field, I think. Well, good. I don't know if there are other questions.
There is one more from, yes, made by Hugo. He asked about the LUCI project, if it can be considered a lunar telescope or several telescopes for interferometry. The question is for
originally, of course, because we were offered the space on the lander, that was idea was only one telescope. But judging by the, it's interesting idea about several telescopes, because as you saw, the cost was not that much, and it's affordable to from universities to small institutes. So several telescopes, we don't mind. Just we don't have the launch. That is the problem.
Mm-hmm.
Oh, well, thank you again. And Beatrice, I do see your note about our time budget, and we should be moving on. Can you tell me again, what is the concluding time that is necessary for our Galaxy Forum?
No, we have not any pressure. Yes, we have time until 7 p.m. here in Argentina, but try to finish before because we need to go home.
Okay.
But we have time.
Okay.
There is no other activity after the Galaxy Forum, so you are the last in the room, and that's all.
Okay. Well, hopefully the last is still good. And thank you. And let us move on after a very interesting presentation. And indeed, Margarita, we have a lot of common interests and pursuits. Very exciting to finally meet you and see your work. And now we'll shift slightly from the moon to precession, constellation considerations, cultural considerations, with a very well-known expert, our next presenter, Dr. César González García, well known for his archaeoastronomy work on precession. He works at the National Research Council, Santiago de Compostela, written many interesting papers on the subject, including a major 2018 paper on astronomy in Roman urbanism. And we are delighted then to hear a presentation from Dr. César González García on the subject of precession and witch equinox.
Hello, everyone. Can you hear me?
Very good. Very good here.
I'm glad to be here, and thank you for the invitation, Stephen, for being part of this Galaxy Forum. Also, I would like to say that I just realized that the program announced me with the precession and witch equinox, because I understood in one of the exchange of emails that I was supposed to talk about the precession and Sirius in Egypt. So if you don't mind, I will present the talk on this topic. Anyway, we can discuss on precession and witch equinox if you want. I can say just a few words. Equinox, from the point of view of cultural astronomy, is one of those elusive concepts that are more related to the cultural point of view of the observer than to a fixed position on the sky. This is why we wrote a paper some years ago about witch equinox, because we were trying to figure out in the Roman calendar which equinox was the one meant by Julius Caesar to make the calendar reform 2 years before his death. In any case, I will now try to share my screen with you. Let me see if I can do it. I hope.
Yes, we can see it.
No, I'm sharing the wrong screen, I guess.
Well, can be.
Yeah. One second. Let me try to fix it.
There we go.
Okay.
No.
Is that their talk?
This
It
was
seems
a
to
talk.
be very interesting. Anyway.
Well, you're seeing the presenter's view. I don't know how I can shift it. Anyway, I hope now you can see it, right?
Yeah. Yes, yes, it's visible.
Okay. Well, I will give a presentation on this topic, the precession and the rising of Sirius in Egypt. Basically because, as Herodotus said, Egypt is a gift of the Nile. In a sense, if there were no Nile, Egypt would be a complete desert today. However, given that we have the Nile, Egypt has one of the most fertile lands in northern Africa, and also due to the to the flood of the Nile, the flooding of the Nile every year, the Egyptians had the opportunity to receive fertile soil every year to promote agriculture in the banks of the Nile, and for a peculiar casualty, this was heralded by the dawn of Sirius a few weeks before of the flooding of the Nile. So they realized this, at least from the Middle Kingdom. We have written records that indicate that they were observing the heliacal rising of Sirius a few weeks before the flooding, so that they could prepare their land for the inundation period. And well, we have very good reasons to believe that even though the written records we have only date back to the Middle Kingdom, they were probably observing Sirius for this heliacal rising even before that. And one of the areas where we can go and see if this was true is in the middle of the desert today, in Napta Playa. Is way far from the Nile, several kilometers away. To give you an idea, Abu Simbel is somewhere here, and this is Napta Playa. Napta Playa today is in the middle of the desert, as I say, but 8,000 years ago, it was in the middle of a savanna, like this image here. This was due for, among other reasons, for the precessional movement of the Earth. That one of the things that made it was that the changes in the orbital inclination of the Earth made that the monsoon rains that now don't go farther up than the south of Sudan or Ethiopia, it went up to this area, and this was a much more humid place with bushes and trees, and able to capture cattle herders as in places like this one, in Napta Playa, where archaeologists in the last decade of the past century discovered large arraignments of megaliths in this area. Megaliths that they were standing stones, many of them, others are stone circles, in very complicated ways, arranged in very complicated ways. And some of them, they were excavated, and they could date it to the 5th millennium BC, so 7,000 years ago. 7,000 years ago, the people were going there, possibly to a shallow lagoon in this area, where they could water the herds, and also build some ritual place for them. We know these are ritual places because there are offerings, there are burials of humans and of cattle in very complicated manner. But also in the year 98, Kim Malvin and their collaborators, they studied this from the point of view of archaeoastronomy, and they found out the following things. For instance, in Napta Playa, one of the things that calls your attention is that when you see the image from above, you can see several linear arrangements of stones, like the ones you see here. The stone marked with A is the largest one in the area. And well, you can see some of the arrangement. Some of these arrangements can be more easily seen from the ground, that they are linear arrangements, and they could measure at least 5 of them very clearly, and they could think that they could be indicating that they were built at different times, but in trying to follow the same object in the sky. For instance, the one to the north, it was supposed to be made to follow the movement due to precession by the brightest star in the northern sky, Arcturus, while the one in the south, it was meant to be following the rising of the star Sirius in the years you can see here, that they fit very well with the chronology that of the archaeologists from the carbon-14 dating. As I said before, there are other arrangements like this one. It's a circular arrangement. The circle is very small, as you can see here, but some of the stones are up in the upright position, almost indicating a line of sight. Kim Malvin and his team, they proposed that in this direction they could somehow be very close to the summer solstice sunrise. It's interesting, but this is a few degrees far to the north of summer solstice sunrise. Conversely, in the other direction, they didn't notice, but it would be facing the setting of Sirius at this period of time. So in this case, even in this position, in this area, we have at least two, let's call them devices, where you can see that they were trying to follow somehow Sirius. We don't know what they were using this for, probably for ritual purposes. Most probably they were not aware of precession. They were just trying to follow the rising of Sirius for some reason, but they realized several centuries later that Sirius had shifted and that the device didn't work anymore, and they had to build a new one. And this was the reason for building these different alignments. In any case, in the Egyptian culture, Sirius was a rather important object. It was called Sobdet. Here you have the hieroglyph, and it was associated to some goddess. As you can see, you will see later, there was a constellation. It was the constellation Sobdet. And for instance, in this Hellenistic ceiling in the Dendera temple, you can see that it is depicted as a cow with a star, and this is the constellation of Sobdet, Sirius, that it was associated to the goddess Hathor, the cow goddess, but also to Isis, one of the main goddesses in Egypt as well. As I said before, it was very important for the calendar. The Egyptian calendar had 365 days without intercalation, the civil calendar. So it was divided in 12 months of 30 days, but plus 5 extra days, 5 days devoted to several gods, among them Isis, for instance, and Osiris. And the year was divided in 3 seasons, Semu, Ahet, and Peret, that they mean the rise, the receding, and the drought of the flooding of the Nile. So it was they were seasons related to their environment, to their milieu, and in this calendar, then it was very important the heliacal rising of Sirius, called Peret Sobdet, because it, as I said before, heralded the period when the flooding was going to happen. Of course, the fact that the year had 365 days without intercalation made that the year shifted along the seasons. So there was the zodiac cycle, where in 1453 years there will be a complete cycle of the whole year movement of the through the let's call them normal seasons. In the last 2 decades, there has been a strong effort by the team of Juan Belmonte and the Egyptian team of Mosallam Saltut to measure a comprehensive set of orientations of Egyptian temples. Egyptian temples have a very standard layout, mostly after the Middle and the New Kingdoms, where we can measure very specific direction of the orientation of the temple. Also, we can measure the altitude of the horizon. Knowing the latitude, we can take the declination and see if there is any kind of agreement with the rising or setting of heavenly bodies in the sky. And here you can see the histogram for nearly 400 temples in Egypt and in Sudan. And you can see that most of them are located very concentrated towards the equinox. It's not exactly the equinox, it's a little bit south of the equinox, but at the same time, this direction would be very close to the cardinal direction. And this is very important in Egypt because the Nile, for most of the geography of Egypt, runs north to south. So at the same time, the temples can be following the sun near to the equinox, but at the same time following the perpendicular or parallel to the Nile. Then we have a second group that is very closely related to winter solstice, but also you can see here the shift of Sirius during the pharaonic period in Egypt, and you can see that there are a number of temples that are associated to this direction. Are they related to Sirius? Well, some of them they might be, and they might include some awareness of the movement of Sirius. One of them is located away from the Nile in Serabit El Kadim in the Sinai Peninsula, next to one of the mines for amethyst, the blue semi-precious stone. It is, well, this is the entrance to one of the temples. There are two temples. They are semi-excavated in the rock. And you can see that it has a very complicated layout. This is due to the different reformations and rebuilds along the different epochs. For instance, the oldest building, I think, is from the Middle Kingdom, while it was built for nearly 1,000 years with different reformations and so on. We could try to find the different orientations of the main temples, but the interesting part here is this main direction to the west, to the southwest, that has different shiftings, and that according to the people that has studied this, it could be related to the rising, to the setting of Sirius during this whole period, where these people would be aware of the shifting of this setting. Why was important Sirius in this case? Well, this temple was, as you can see here, devoted to Hathor, one of the goddesses that was related to Sirius, and this was the main temple of this area. An area, by the way, very humid, very warm, and where no mining activities could be done after the heliacal rising of Sirius. Precisely. So at the same time, they had the goddess, and they had also the means to know when they had to leave if they want to survive the heat in the area. Another area where we can see importance of Sirius is in the Sudanese area of the Nubian temples and pyramids. Here you can see the difference with the histogram before, where you can see the importance of Sirius also for the Sudanese temples. But most importantly was this for the orientation of the pyramids of the Nubian kings. You can see here for 128 pyramids in Sudan, one of the main concentrations is facing directly towards the setting in this case, the rising in this case of Sirius. Finally, in the last 3 centuries before Christ, we have the Hellenistic period, where one of the most important facts for the discussion here is that, well, Hipparchus, although it's not clear if he ever worked in Alexandria, discovered or at least described correctly the precession. And according to Ptolemy in the Almagest, he was using the work by Timocharis and Aristylos to make his own stellar atlas, and found the difference in position and explained it with the precession of the equinoxes. This is interesting because we have at least one temple, the one in Dendera, as I saw before, where we have this beautiful sky map. This temple, the last reformation took place in 56 BC, right? A few, say 100 years, a bit more than 100 years after Hipparchus described precession. And we can see that the main temple faces towards the Nile, but the secondary temple devoted to Isis is not perpendicular, exactly perpendicular to the main temple, and it has a shifting with a previous temple that make us think that this is also an area where they were aware of the shifting of Sirius, and in this case it was built when the precession was known, so probably the priests also knew that that they needed to follow this precessional movement. I would like to end by saying that with the conquest of Egypt by Augustus, it was the Egyptian culture didn't die. One of the heirs of this culture are the Christian Coptic that are still in Egypt today. They are nearly 10% of the population there. And it's interesting that if we measure the orientation of the churches, most of them, they of course are facing near the equinox, as is meant to be for a Christian church, but there is a significant concentration for the nations that are consistent with Sirius as well. And this is not surprising, as they have some festivities. For instance, one of them devoted to the Nile to give some gifts to the Nile, so that the year is going to be good for agriculture. I believe this is all. I would like to end by saying that precession, as I said at the beginning, was important for the geographic conditions. For instance, in Nata Playa, Sirius was perhaps and still is the most important start in Egypt. Was precession known during pharaonic times? Most probably not before Hipparchus. Most probably not, but they were aware that from time to time they needed to shift the temples, just because the temples needed to be, some of them, facing particular objects in the sky that were affected by precession. Only after Hipparchus, we have at least the evidence that the Dendera temple was probably the first one, so to say, built aware of precession in Egypt. And well, I would like to thank you again, and I hope you enjoy the presentation.
It was a great presentation. I love it. You are mute, Steve.
Thank you. Wonderful, wonderful presentation, César, on a perennially fascinating topic of Egypt, its most important star Sirius, and the precession analysis that you've made regarding the history of the knowledge of precession, and a lot of questions to be followed there. And I won't offer any at the moment. I don't know if others have, but I will be following up. My associate Labiba and I, who happens to be from Egypt originally, will have lots of questions to put to you. So very appreciated your topic. It was on cue. It was on point on precession as it relates to antiquity and its progression through the ages.
You have a question at the chat if you want to answer. Can you see the question at the end of the list of the chat? It's Rosa Ross who is asking, in the Nubia graphic, yes, there were two important, okay.
Yes, I can see that there were two important concentrations. Yeah, the largest one was a little bit further to the south. It was actually very close to due south. So we tend to believe that it might have been related to due south, although there could be some indication that there could be any other interest in some other stars, but I would be quite cautious to claim. Could I email your PowerPoint? Yes, no problem. Sure.
If the speakers, if the speakers are agree with this, the idea is to upload at least the link to the presentations, the PPTs, at the website of the symposium. So you don't need to send to me or anyone the presentation, just share the link to your own drive or Dropbox or wherever. If you share the link, we will upload the link at the website in the same way that we have the posters. So send to me, send to us, to the log, the link, and well, as soon as we can, we will share the presentations.
That's agreeable then, Dr. González?
Yes, sure. Yes,
Wonderful,
yes,
wonderful.
Great.
So we'll be able to have access to that information immediately or directly. Thank you so much for that suggestion. And once again, a great presentation. I'd like to study it and follow on. We need to move on. We've had great presentations on the moon, on constellations, on precession, and now another stellar presentation by Dr. Santiago Paolantonio, who's devoted a great deal of time to researching precession. One of his landmark papers was the Argentinian attempts to prove the theory of general relativity in regards to the total solar eclipses of 1912, 1914, and 1919. And I imagine that this paper would be able to shed some light on the upcoming eclipse as well. And Dr. Paolantonio is a member of, teaches at the University of Cordoba in Argentina, and we're happy to host his presentation on history of precession, constellations, and Uranometria Argentina, a fascinating story that will be unfolding. And I need to explain that Santiago's presentation will be in Espanol and Spanish, and I've been provided by Dr. García, by Beatriz, with a good translation, or from San Antonio, Santiago, excuse me, and that's how we'll proceed. If that's okay, Santiago, you can go slide by slide and make your presentation in Spanish, and I will translate in English, and then you will go on to the next slide, if that's okay.
Yeah, thank you.
Gracias. So we will look forward to Dr. Paolantonio's presentation on history of precession, constellations, and Uranometria, Argentina. Please.
Bien, good afternoon. Un gusto de estar con ustedes, gracias por la presencia y bueno, vamos a iniciar con esto.
Good afternoon, a pleasure to be with you. Thanks for coming.
En una noche sin luna.
¿Estás compartiendo, Santiago?
Sí, yo te estaría compartiendo.
No
se ve.
No lo estamos viendo todavía.
Vamos. De vuelta.
A ver si tienes algún problema.
A ver.
Teóricamente no tenés.
Compartir.
Ahora
Ahí.
parece que sí. Espera un segundito.
Sí.
Ahí está, pero en modo, no está en modo presentación todavía.
Ya la paso.
It looks good.
Ahí se ve.
Sí, ahí se ve.
A ver.
No, ahora se te fue.
No sé por qué no aparece. Ahí está.
Sí, ahí veo la diapo 2, que no tiene texto, ¿verdad?
La diapo 2. Bien. Ahí está, no tiene texto. Estamos, empezamos
sí, okay.
Entonces.
Sí, dale.
Bien. Les comentaba, en una noche despejada sin luna y con poca contaminación lumínica, uno a simple vista puede ver 3.000 estrellas. Este espectáculo nocturno, desde tiempos remotos, llevó al hombre a imaginar figuras con las estrellas y con los espacios oscuros que le permitieron un modo u otro explorar los cielos y las tierras, ¿no?
Yes, on a clear night, without the moon, clouds, or haze in the sky, and far from all light pollution, with the naked eye, you can count more than 3,000 stars in the sky. This nocturnal spectacle that from ancient times captured the attention of human beings induced different civilizations to imagine figures, grouping stars or dark areas, which served as a guide to explore the celestial sphere and new lands.
En China se imaginaron dragones, en Medio Oriente, en Europa, deidades, gigantes, más tarde una cruz. En América, pisadas de ñandú, braceros. Hoy, digamos, todas estas estaban relacionadas de alguna manera con narrativas propias de cada uno de estos pueblos, ¿no? Hoy las posiciones de la mayoría de las estrellas, de todas las estrellas visibles, incluso de las estrellas que se observan con instrumentos, están determinadas con precisión. Con estas coordenadas uno podría ubicar claramente cualquiera de las estrellas. Sin embargo, aún se conserva las referencias a la constelación a la que pertenecen. Una tradición que de algún modo es conservada por los astrónomos y de este modo, en este caso particular, que proviene de los orígenes mismos de la ciencia, ¿no?
Okay. In China, they imagined dragons. In the Middle East and Europe, deities, giants, and later a cross. In America, Rios, footprints, and braziers, all images linked to the narratives of different peoples. Today, the positions of visible stars to the naked eye and of the large number of ones with instruments are recorded in catalogs with great precision and accuracy. Although these data would be enough to locate each of these stars unequivocally, today they continue to be related to the constellation in which they are located, following one of the many traditions jealously guarded by astronomers, in this case, originating from the origins themselves of this science. Okay.
Actualmente se admite la división de toda la esfera celeste en 88 constelaciones, de acuerdo a la propuesta de la Unión Internacional, la Unión Astronómica Internacional. Esto nace desde los inicios mismos de la Unión, en 1919, cuando en la primera asamblea, en 1922, se resuelve la denominación de las constelaciones según su nombre latino, en latín, perdón, y las abreviaturas con tres letras. Y posteriormente, en la siguiente reunión, el Comité Nacional Belga de Astronomía examinó la cuestión pendiente referente a los límites de las constelaciones y le impuso a un astrónomo del porte la responsabilidad de delimitar teóricamente esos límites, ¿no? De definir teóricamente esos límites.
Okay. The current astronomical community unanimously accepts the division of the celestial sphere into 88 constellations, according to what was established by the International Astronomical Union. After the formation of the Union, in the first assembly of 1922, the exclusive use of the Latin names for the constellations and their abbreviations was resolved with a three-letter system. In the following meeting, the Belgian National Committee of Astronomy examined the pending issue of the limits of the constellations, presenting a motion to review them. The astronomer Eugene Delporte, his picture there, was given the responsibility of the complete theoretical demarcation. Okay.
Las constelaciones actuales derivan de alguna manera de las 48 constelaciones señaladas por Ptolomeo en el Almagesto y por otras que fueron incorporándose por viajeros y astrónomos europeos en los últimos siglos.
These constellations derive mainly from the 48 indicated by Ptolemy in the Almagest, as well as those introduced by European navigators and astronomers who observed the southern skies in recent centuries. Okay.
The problem. ¿Cuál era el problema? Perdón. Más o menos hasta 1600, casi todas las estrellas estaban se ubicaban según la posición en las constelaciones y por la alineación entre las estrellas, un sistema sin duda ambiguo e impreciso. El que sumado al hecho de que las constelaciones fueron cambiando en cantidad, en denominación a lo largo del tiempo, produjeron un caos en relación a la identificación de las posiciones de las estrellas en estos asterismos. El escenario comenzó a cambiar lentamente a partir del siglo XVII, con propuestas que quisieron Bacher, Herschel, Lacaille, pero de todos modos, aún en el siglo XIX, la confusión era mucha y el caos era muy, muy grande.
Okay.
Adelante.
Thank you. Before 1600, almost all stars were designated by their locations in the asterisms or by alignments between them, an ambiguous and imprecise method which added to the fact that the constellations changed in number and name over time, resulted in real chaos. In particular, the limits were not defined and varied according to the astronomer who observed them, who usually took great liberties. This anarchic scenario began to change in the 17th century thanks to contributions of notable astronomers such as Johann Bayer, John Herschel, and Nicolas de Lacaille, among others. However, 2 centuries later, identification errors were still common.
Esta situación se había tornado insostenible en el siglo XIX, en un momento en que los instrumentos habían alcanzado un desarrollo notable, las posiciones se registraban por decenas de miles y en general los estudios astrofísicos comenzaban a desarrollarse. Resultaba de gran importancia el definir la situación en relación a los estudios vinculados con los meteoros, los bólidos, las estrellas variables y la observación de novas.
This situation was untenable at a time when astronomical instruments had reached astonishing perfections. Stellar positions were recorded in the tens of thousands, and astrophysical studies were beginning to develop rapidly. It was important for a large number of astronomical works, for example, the observation of meteors and fireballs, the study of variable stars, and the observation of novae.
La solución. En su trabajo presentado en 1930, Del Porte tomó como referencia una obra que había visto la luz un medio siglo antes, la Uranometria argentina. Adelante, Steven.
In his work presented in 1930 to define the constellations and their limits, Del Porte took especially into account what was done half a century earlier in the famous work of the Uranometria Argentina.
La razón de emplear la uranometría argentina se fundamentó en que en esta obra se realizó una investigación muy detallada en vinculación a, por un lado, las denominaciones estelares, y se propuso una definición de los límites de las constelaciones en base a arcos de declinación y de ascensión recta, eligiéndose de una manera tal de que minimizara todo lo posible que hubiera demasiadas diferencias con los atlas existentes en la época y de que las estrellas cambiaran de posición en cuanto a su ubicación en las constelaciones. Adicionalmente, la uranometría realizó por primera vez una extensión de la escala de magnitudes de la sexta a la séptima.
Gracias. The reason for using the Uranometria Argentina was based on the fact that in this work a detailed investigation was made of the current situation at that time, unifying the stellar denominations and solving a proposal of the limits of the constellations, which used arcs of right ascension circles and parallels of declination, choosing them in such a way that they did not deviate too much from those used in the most important atlas of the time, and minimizing the changes of belonging of the stars to the constellations. In addition, the magnitude scale was extended to 7.
Para los mapas que acompañaron al reporte del porte, también utilizó la misma proyección que la empleada en la uranometría argentina. La dibujó incluso en la misma escala, aunque luego se reprodujo a un 40% por una cuestión de economía. Pero lo más notable es que utilizó el equinoccio de 1875 como la uranometría argentina, a pesar de que ya hacía rato que se empleaba el de 1900, con la expresa intención de que la propuesta estuviera, digamos, integrada en un conjunto con la uranometría del sur.
For the maps that accompanied the report, the projection chosen in Uranometria Argentina was also used. Although they were drawn on the same scale, for reasons of economy, they were published in a smaller size, of only 40% of the original. Delporte opted to use the reference equinox of 1875.0 to coincide with the southern uranometry in order to form a set with it, although by that time the positions were already given reference to 1900.0.
Como mencioné, una de las cuestiones importantes vinculadas con la definición de los límites de las constelaciones se relacionaba con las estrellas variables, y en este sentido también la uranometría argentina hizo una diferencia de alguna manera, pues al momento de la publicación se incluyeron más de 200 estrellas variables o sospechosas de serlo, en una época en que los catálogos no superaban no registraban más de 1,5 centenario de este tipo de estrellas.
As Professor Santiago mentions, one of the most important reasons for the need to clearly define constellation boundaries was the issue of variable star names. Again, in this aspect, the Uranometria had great importance, since in the same 208 variable or suspicious stars being in it were included, in a moment in which the known list did not surpass 100.5.
Bien. La uranometría fue publicada entre 1877 y 1879, ¿no? Fue producto de un trabajo realizado en el Observatorio Nacional Argentino, que fue inaugurado el 24 de octubre de 1871. El próximo año se cumplen 150 años. Y su primer director fue el astrónomo norteamericano Benjamin Gould, el que planificó la realización de esta uranometría, pensando en integrar de alguna manera de completar y complementar hacia el sur lo realizado por su maestro, Iii Lander, en Bonn, con la uranometría nova. De modo que en forma uniformemente se iba a poder tener una visión global de todo el cielo visto a ojo desnudo. En realidad la uranometría nace como consecuencia de un atraso en la llegada de los instrumentos destinados al observatorio, que no llegaban debido a la guerra franco-prusiana, que impedía la salida de los barcos desde Alemania.
The new southern uranometry was made between 1870 and 1879 at the Argentine National Observatory, inaugurated in the city of Cordoba on October 24th, 1871. Its first director was Benjamin A. Gould, who planned the southern uranometry as a replica of the Nova uranometry of his teacher Friedrich Argelander. The work was mainly a product of the delay in the arrival of instruments from Europe, a consequence of the Franco-Prussian War.
La primera observación se realizó el 14 de noviembre de 1870. Fue efectuada por uno de los 4 ayudantes que junto a Gould comenzaron el observatorio. Fue William Morris Davis el que hizo esta primera observación. En realidad, los 4 ayudantes hicieron las primeras mediciones desde sus casas que estaban ubicadas en el centro de la ciudad de Córdoba, porque en ese momento todavía el edificio del observatorio estaba no había sido terminado. Y todo fue rigurosamente anotado en libretas que aún se conservan en el Museo del Observatorio Astronómico.
The first observation occurred on November 14, 1870 by assistant Williams Morris Davis. The first measurements of position and brightness made by the assistants from their lodging in the center of Cordoba City, since the observatory headquarters were still under construction. Everything was recorded in detail in notebooks.
Entre los 4 ayudantes se destacó por la revisión que llevó adelante John Thom, el que llegó en 1870 a Córdoba. Tom, como el resto de ayudantes, no tenían formación astronómica, así que su formación como astrónomo se llevó adelante en el Observatorio Nacional Argentino, y él posteriormente, en el 85, asume la dirección de la institución y continúa en la ciudad hasta su muerte a principios del siglo XX, así que de alguna manera uno puede considerar a Tom como el primer astrónomo profesional argentino, teniendo en cuenta que se trata de una tierra de inmigrantes.
Among the observers, John Macon Thome stood out and carried out a deep review of the work. Young Thome arrived in Cordoba in 1870 and assumed the direction of the National Observatory in 1885. He trained as an astronomer in the country and died in 1908, which is why today he is considered the first Argentine professional astronomer.
Mientras los 4 ayudantes realizaban las estimas, las mediciones, las revisiones, cálculos, el director Gould se dedicó a estudiar en detalle la distribución de las estrellas en el cielo, fijar la escala, como comenté, hasta la magnitud 7, y en particular dedicó un gran esfuerzo a la estandarización de los nombres de las estrellas y los límites de las constelaciones, ¿no? Con la expresa intención de superar todas las ambigüedades que existían en la época. Expresamente el director comenta la importancia de definir justamente los límites constelacionales de una manera rígida, principalmente en relación con las estrellas variables, que era en ese momento un campo de investigación que se estaba desarrollando ampliamente.
Gracias. While the body of astronomers of the observatory made the estimates and measurements, revisions, and the necessary calculations, Gould investigated in detail the distribution of the stars in the sky, fixed a scale of magnitudes up to the 7th, and in particular devoted enormous efforts to standardize the stellar denominations and the constellation boundaries, with the express intention of overcoming the many ambiguities existing at the time. The director stresses the importance of the boundaries of asterisms being rigidly and unequivocally defined, particularly in relation to variable stars, objects that began to be the focus of ever greater attention of the astronomical community at that time.
Gould realizó muchísimas consultas con distintos astrónomos, en particular con su maestro Lander, y se ocupó de estudiar cada uno de los catálogos y atlas existentes y tomar en cuenta propuestas realizadas por ejemplo, Bayer, Lacaille, Herschel, y de otros diferentes astrónomos.
Gould conducted long consideration and consultation with other astronomers, particularly his teacher, the German astronomer Lander. He carried out a detailed analysis and comparison of the stellar names and limits of the constellations suggested by Bayer, Lacaille, and Herschel, as well as the different proposals made by different astronomers.
En esa oportunidad, en la uranometría se abandona definitivamente la constelación Argo. A pesar de que de alguna manera le costaba mucho a Gould, incluso él dice textualmente: el total abandono de la venerable constelación Argo me ha causado mucho sentimiento, pero no dejará de existir, quedando representada por sus descendientes legítimos, en relación a las constelaciones que había, en las que la terminó dividiendo en Puppis, Vela y Carina.
On this occasion, the Argo constellation is definitely abandoned, as you've seen. Excuse me, I'm missing a slide. On this occasion, the Argo constellation is definitely abandoned, much to the regret of the director, who points out, as we saw on the slide, the total abandonment of the venerable constellation Argo has caused me much regret. Yet it will not cease to exist, being represented by its legitimate descendants.
Bien, dentro del trabajo realizado en cuanto a la distribución de estrellas en el cielo, uno de los resultados fue justamente el descubrimiento del conocido cinturón de Gould, esta estructura estelar que aún hoy es sumamente estudiada, ¿no?
It is also in this work that the discovery of the stellar structure known today as Gould's belt is described, which is currently highly studied.
Bueno, el atlas de la uranometría argentina finalmente fue publicado en 1877 en Nueva York, mientras que el primer tomo de los resultados del Observatorio Nacional Argentino se publicó en Buenos Aires en 1879. El atlas tuvo distintas reediciones en 1905, en 2001 y en 2010. El tomo 1 incluye no solo el catálogo, sino también todas las técnicas empleadas e incluso la historia de la obra. Mientras que el atlas lo componen 13 mapas de gran tamaño, de 50 por 70 centímetros, el catálogo incluye 7.755 estrellas hasta la séptima magnitud y un décimo más, un poco más de 700 estrellas más de mayor magnitud. Todo esto abarca desde el polo sur celeste hasta la declinación más 10 grados.
The atlas was published in 1877 in New York, while the catalog and job description in 1879 in Buenos Aires. In 1883, the work was awarded by the Royal Astronomical Society. New editions appeared in 1905, 2001, and 2010. Volume 1 of the results of the National Observatory has 400 pages that include the history, technique used, analysis of the data, and the catalog in Spanish and English. And the atlas consists of a separate volume with 13 maps, 50 by 70 centimeters. The catalog contains the positions and brightness of 7,755 stars up to the 7th magnitude and 707 fainter between the South Pole and 10 degrees of north declination.
En resumen, los límites de las constelaciones actuales se definieron tomando como referencia la propuesta realizada en la Uranometría Argentina, y esta elección no fue arbitraria, sino consecuencia de la calidad y la precisión del trabajo realizado en el Observatorio Nacional. Se trata de un capítulo, un pequeño capítulo de la historia de astronomía, pero que es muy poco conocido, pero que realmente considero que vale la pena que no caiga en el olvido, ¿no?
In summary, as we can see, the limits of the current constellations were defined taking as reference the proposal made in the Uranometria Argentina. This choice was not arbitrary, but a consequence of the quality of work done in the Argentine National. It is a little-known chapter in the history of astronomy that is worth rescuing from oblivion.
Thank you.
Gracias. Thank you. Excellent paper, very informative and comprehensive historical presentation. Gracias, muchas gracias. And Eugene Delport, who fixed the constellations that we all referenced today. That was a wonderful presentation, Santiago, and I certainly appreciated it. Much information. Is there a question? Perhaps Dr. Garcia, do you note a question, or is that just a follow-on from the last speaker?
I have, yes, we have some questions. Can you hear me?
Yes.
Okay, and wait a minute.
Right.
Sorry, I have another. Oh, wait a minute. I have another screen, another computer. Sorry. Well, Walter Guevara asked about the maps. If the maps are digitalized, si están digitalizados los mapas, Santiago.
En 2001 se digitalizaron, luego se digitalizaron en varios lugares. Sí, está disponible incluso en la web, en el blog.
¿Querés compartir la dirección web del blog, Santiago, en el chat? Santiago will share the blog address. It's a website created and maintained by him about the history of astronomy, Argentinian astronomy. A very, very interesting website. She will share in a few seconds the link if you want to visit it. It's in Spanish, but it's a very, very good repository of the history of astronomy in Argentina, with very interesting articles written by prominent astronomers even. So it's very, very interesting. Well, I have not more questions to Santiago in the chat right now. I don't know if anyone else want to ask Santiago something right now. It's the moment before the last talk.
Well, I'm very interested in knowing about the Argentinian attempts to prove the theory of general relativity, studying the eclipses, and how will that be studied in the upcoming eclipse? The results used to increase our understanding with the upcoming eclipse, understanding of relativity.
Sorry, are you asking about the previous intent to prove the theory before 1919?
Well, this was from his landmark paper, and perhaps I shouldn't digress on that question at this time. I do have other questions, but the presentation, which needed the translation into English, and it was an excellent translation, very easy for me to follow, did take up a good deal of our time. So I will have to follow up, Dr. Santiago, with you on future questions and our strong common interest in the history of precession and stellar cartography. And so I wanted to thank you again for a very major effort and much appreciated. Very, very studious and comprehensive. And now we'll move to gracias, muchas gracias, Santiago. Thank you much. I appreciate your patience. The translation took a little time. We've had interesting presentations, and as usual, went a little bit over on our schedule, but fortunately, Dr. Beatrice mentioned that we are the last event of the day, so we're okay with a final presentation now from China by Dr. Li Geng. And Dr. Li is the only one of my associates on this Galaxy Forum who I'd met in person about a year ago in Beijing with a very interesting introductory discussion. The subject that Dr. Li is expert on, ancient Chinese astronomy and precession. Dr. Li works at NAOC, where I visit very frequently the last 20 years or so. NAOC in Beijing. He's published many papers, numerous interviews about astronomy and culture in ancient China, and one of the handful of experts on the subject of gnomon shadow measurement, and one of the first, which was one of the most fundamental astronomical observatories in ancient China. So we're very fortunate and happy to welcome Dr. Li to make his presentation, Tracking Precession in Ancient Chinese Astronomy. Geng, please go ahead. 谢谢.
Hello. Yes. Can you hear me? Hello.
Yes, we can. If you
Yes,
need to share the screen, try,
yes.
please.
In the middle of the night for you, I guess.
Yes, it's 4:30 a.m. in Beijing. So.
Well.
Hello, everybody, and thanks for the invitation from Steve. And I'm new for the symposium, so I'm afraid I can't get all of the points exactly. So I'd like to show you a series of pictures and make a general introduction of ancient Chinese astronomy, especially the evolution of the star catalog, star charts, and as well as the astronomical instruments. So in China, we have some words from the ancient literature like this. We call that, we can infer from the ancient literature that in very ancient history, from very early period of time, the ancient Chinese people began to make the measurements of the skies. So from earlier than the 3 generations, which is approximately 3,000 or 4,000 years before, everybody knows about astronomy. So they measure the celestial phenomenon by granting the seasons. So this poem is from Ming Dynasty, about maybe 600 years ago. That's before the 3 generations. Everybody knows astronomy, and like from the farmers' words or women's whispers or soldiers' writings or children's songs, we can know things about the season changing. And also in Chinese, we have 24 histories. So from the 10th century, during the Northern Song dynasty, a new tradition was established to be the supplement of history, like the Song Hui Yao, which can be translated to the Song government manuscript. And in Song dynasties, there are many institutions established by the royal government for recording the history of a celestial phenomenon, like the National Archives or the Institutes of Editing, the Institute of National History, and etc. So most of these institutes are independent, which means the events can be recorded independently. That's why sometimes you will find different descriptions correlated to the same astronomical events after the 11th century. And that is also one field that I'm especially interested, like the historical supernova or some other comets or many celestial phenomenon. And this is in the Song Hui Yao, the Chinese book, and we can find many clues of the ancient Chinese. Also, some many valuable information can be preserved in the chronography. We have many ancient books preserved. So like this, it described some stories, maybe for the 2,000 or 3,000 years ago, and it's preserved it's especially for the Sichuan province at the southwest China. And there is also some descriptions on the whatever occurred in the sky in the ancient times. And there is also some official bureaus for the Bureau of, we call it maybe Bureau of Astronomy, like the Qintianjian in China, we call that. So now if you visit Beijing, you can find there is a Beijing Ancient Observatory. And there is a board hanging in the center of the hall. So the 4 characters was written by Emperor Qianlong in 18th century. And it means the season granting by observing the sky. It indicates that one of the most important assignments for the Bureau of Astronomy in ancient times. So actually, there are 3 totally assignments for the Bureau of Astronomy. One is the making calendar, and the second is time service and monitoring. The third one is monitoring the abnormal celestial phenomenon. And from the very early time, for example, this case is 6,000 years ago, we find in a tomb in Henan province, we can see a dragon and a tiger pattern is made by seashell in the tomb. And this is the imagination of the Chinese ancestors for the sky. So they make the constellations like this. This is the pattern is. And also about 4,000 years ago, approximately 430 BC, we found this painted wooden box in another tomb, and it's excavated in we call it some Zhenghouyi tomb. It's in Hubei province in the center part of China, and in this wooden box, we can see the patterns, the paintings. It's 28 lunar mansions. And at the center is the Big Dipper, and around it are 28 constellations. So this is the earliest clue we can find right now. At about no later than the 2045 to 23 BC, we find another seeding constellation. It's painted in a Han tone, and it's in Xi'an in the south, it's known as northeast China, and in Xi'an Jiaotong University. And from this painting, we can also see that the center is the north pole of the sky, and around is the 28 lunar mansions. And this is a painting at approximately 6th century. It is a star chart painted on another seeding in a Yuanyi tomb in the North Wei period. And from this painting, we can see there is a Milky Way at the center, which means the ancient people have already made a series of observations at that time. So it looks much more, maybe we can see much more accuracy than the earlier ones. It's not just a symbol of the sky, but we can see the constellations very clear. And till now, we can find the earliest star pictures, the star maps. And the earliest star map is preserved right now in British Library, and it's the Dunhuang Star Map. Dunhuang is a place in the northwest China, and it's far from the capital Chang'an at that time. But some ancient literatures was preserved well in Dunhuang. So this is one of the earliest one. We call it the Dunhuang Star Map. It was made approximately at the 7th century. And from this map, you can also see its very accuracy and the progress of the astronomical observation and astronomical star maps. And about 400 years later, in Song Dynasty, the ancient people made stone inscriptions. So we now call it Tianwen-2, is star charts, very famous star charts. If we enlarge the star charts, we can take a close look. Please notice that in the outer circle that presents different geographical positions. The ancient Chinese people believe that there's a correspondence before the heaven and the men. So from the Song inscription star map, which was made during the Southern Song period, we can learn that there's a dividing line on the star map that is correlated with the ancient Chinese astrological theory. So if there is an abnormal celestial phenomenon happens, the astrologist will have to determine what does that infer from the country or for the emperor himself. And the Chinese asterisms are generally smaller than the constellations of the Hellenistic tradition. As the Song Dynasty star map shows, there are totally 283 asterisms, comprising a total of 1,565 individual stars. The asterisms are divided into 4 groups: the 28 mansions along the ecliptic and the 3 enclosures for the northern sky. The southern sky was added as a 5th group in the late Ming, based on the European star charts, comprising an additional 23 asterisms. There is the earliest history that we know can be traced to Emperor Yao, which is approximately 4,000 years ago, as recorded in Shijing Tu Shuo, which is comprised by emperor in Qing Dynasty. The Emperor Yao convinced Xi and He as the earliest royal astronomer at about 4,300 years ago. So at the very beginning, people can only live by collecting food. That determined people have to live separately, and population cannot be very large. And the discovery of agriculture assumed a guaranteed burst of population. The people began to live together and they work together, but agriculture is deeply relied to the astronomical observation. So that's why the origin of the ancient Chinese astronomy is approximately at the same year with the agriculture in China. So it's a very, very old tradition. And as we have made the archaeological progress, we found this agriculture. Of course, it's reconstructed by us about 10 years ago. And the base of this agriculture was excavated by archaeologists in 2001. It's located in Shanxi province, which is about center part of China. And this structure was used to make the observation day by day. So with these observations, you can infer that which day is not, which day is today. So we call it as a horizontal calendar. And this drawing from the Taosi Observatory is about 4,300 years ago. And if you observe from the observing point, you can see the sun appear from different slots every day, like in summer solstice or in winter solstice or the equinox, the sun appear from the different slots. And this picture was taken by me in 2007 at the morning of the spring equinox. So we can clearly see that the sun is precisely appear from the center slot of the observatory. So the slot is very thin. We can see the diameter of the sun is not very large, so it's approximately equal, which means you can precisely observe the sun, precisely determine the date by observing the sunrise. So this is very clever architecture. Another method the ancient Chinese people used is Norman measurements, which Steve had introduced in the opening speech. So ancient Chinese people like to use this kind of very, very simple astronomical instruments. It's just a stick. We put the stick on the ground, and then we measure the length of the shadow. We can get many informations. So this tradition was also very long because this we call it the Norman template. It's just like a ruler is to measure how long the stick is. And we found these parts of the sticks also in Taosi size. It's approximately 4,500 to 4,300 years ago. And this is very interesting astronomical instruments. So from these instruments, we can see that there are many pink indicators. So this used to measure the length of the shadow. Then we can also determine the date or the time by measuring the length. This is a typically Norman. It's in the later time. It's now preserved in Henan province. From this Norman, we can see there's an indicator at the top, and it's been improved by Guo Shoujing in the 12th century. And there is a horizontal plane on the template. When the ancient people measuring the Norman length, they put water in it, and they see the water is flat. It means it's horizon. It's horizon. And we can also see the summer solstice and the winter solstice. and this Norman template is located from the north and south direction, and then at the noon, right at the noon, if you measure the Norman shadow, you can see what date is today. And this is a universal modeling. The ancient people make a series of modeling based on their observation of the sky. So they put the universe into different circles. I think it's very similar with the ancient Greeks. And but differently in for Chinese people, we have a different system, constellation systems. So at the center of the sky, we call it the purple forbidden enclosure. And this year is also the 600th anniversary of the Forbidden City, the Palace Museum of China. So the Forbidden City is the name of the Forbidden City comes from the purple forbidden enclosure, which means the ancient Chinese thinks that the emperor must have lived in the North Pole of the sky. And another enclosure is called the Supreme Subtlety enclosure, which refers to the government. Means there's a government on the sky. And the third one is the celestial market enclosure, and it's just like the markets, the citizens are living on the sky in this enclosure. So at the last part, I like to see as we see the evolution of the development of the precession in ancient China. So we have to mention something about the astronomical instruments. It's just like the something related to the astrology. About 2,000 years ago, there is an astronomer whose name is Luo Xiahong from the Sichuan province. And he was a Chinese astronomer. He's a folk astronomer from the southwest China. And he's one over 20 astronomers who traveled to Chang'an, the capital of China, to propose a new calendar system for the emperor. It was not uncommon for the emperors to introduce new calendars in order to place the greater emphasis on heavenly bodies that were seen as particular astrology relevant to the particular ruler. So at the time in the Luo Xiahong's period, he thinks that the calendar was not accuracy. So he made a series of constellations using this kind of astronomical instruments. He invented this. And this tradition has lasted to the very end of China until the late Qing. So this instruments is now still preserved in Nanjing in the Purple Mountain Observatory, and is made about 500 years ago. It's called the Aluminium Sphere. We say in China, we say it is a Hun Yi. And the ancient people used this kind of instruments to measure the sky precisely. There's a tube at the center. They use the tube to find the certain stars, and then you can read the indicators from the circles, and then you get the accurate precession. During the late Ming to early Qing dynasty, the emperor had made a series of astronomical instruments, and from this series of astronomical observation, we have we can see very, very good results. But actually, as you can learn, this instrument is just like the Tycho Brahe from the European. So after 15th to 16th century, the European tradition have transmitted to China and made great conflicts with the ancient Chinese tradition. But of course, the result is the European tradition won. So the Chinese has made a series of European style astronomical instruments. So that's all of my talk. I am not quite familiar with what they are going to discuss before the speech, so I have little time to make the preparation. But I hope this presentation with a series of pictures that you can enjoy it. Okay, thank you.
Yes, well, 谢谢你, thank you very much. A wonderful presentation. As Rosa Maria Rose noted in her chat comment, thanking Geng Li very much. She's interested in his help for developing courses for the teachers. And she'll be getting back with you, Geng Li, in the next few weeks. We've had 6 really excellent high caliber presentations on our Galaxy Forum South America, the first one in Argentina, virtual that it is, on the subject of precession constellations, epochs, including the Aquarius Equinox epoch, and astronomy from the moon. We've traveled from the Argentinian CONAE antenna dishes and astronomical and space research to with Dr. Colazo, a couple of moon missions, including the ILO1, the ILOX, and Dr. Safonova's LUCI mission, the UV mission to the moon, and then a precessional historical overview of astronomy in ancient Egypt by Dr. César González García. A very thorough paper and complementing ancient Egypt, the paper we just heard by Dr. Li on ancient China, the presentation from India on the moon, and the excellent overview of the development of Argentinian astronomy, the Uranometria by Santiago, Dr. Paolantonio. And I'm very, very happy that we have a recording of this. I hope it's a good one that will be made good use of. I know that's certainly the case with ILOA and our studies. We'll dig into these presentations. I want to thank all of our presenters for your patience and perseverance. Those are the watchwords of today. Resilience. We all need to be resilient and persevering in these challenging times. I think our questing out into the cosmos to ask the questions and make the discoveries, and the landings on the moon and Mars are the best solution to transcending and finding answers to problems that confront us here on Earth. Thanks also to the many online attendees. I think there were well over 50, which was a very nice nice attendance and participation. And thanks most of all to Dr. Beatriz Garcia and her dedicated team to make this Galaxy Forum within the IAU S367 symposium as interesting and productive and enjoyable and successful as I believe it was. I won't hold you anymore. If there's a concluding urgent comment, please speak up. And Beatrice, thank you so much. I apologize for all the astronomical time that was taken in our learning here, but I think it was well worth it, and I'm very appreciative.
No, thank you for this event, the first associated event to the symposium. As you can see, there are a lot of people who is sending the congratulations for the talks. Here is Gudrun and Jay Pasakov and well, I don't want to forget anyone, but there are a lot of people devoted exclusively to the history also. So the talks about Egypt and China were great. I love it. Yes, I will put all the talks at the channel, the YouTube channel. So I found these talks very interesting for all the assistants to the symposium, and this was the only place to see these talks. So the talks will be available tomorrow for everyone. And well, here all the people say that enjoy the presentation of each one very much, and just to give my thanks and the thanks for all the team here, all the crew. And I don't know if the speakers want to have the last word for the Galaxy Forum. Anyone of the speakers to say goodbye at least?